Sorry, example number 3 here. Margot and Ravi are also trying to get their parents to let them stay up late or later. They collect data about the number of hours of sleep that a random student sample of seventh grade graders get each night. The two box plots show their data. Do Margot and Ravi's data support Sasha's inference that most sixth or seventh graders in her school get between 9 and 9.5 hours of sleep each night? So let me preference by saying that there are multiple answers to this. There's multiple ways that you can interpret this data to support what answer you may want to provide. So that's my first heads up. What we need to understand is really how a box plot works. And I think a lot of you guys do know that this is the middle or the center of our data. So each of these are the middle. And then here is our first quartile or quartile 1. The middle is quartile 2. And then this out here is quartile 3. So what does that really mean? Is for each of these graphs, 1/4 of the data falls from our minimum to our first quartile. That's 1/4 of our data. Then the next fourth of our data is quartile 1 to quartile 2. Our next fourth is quartile 2 to quartile 3. And our last fourth of our data is quartile 3 to our final maximum. So looking from two of those critical points, you're looking at half of the data, right? So would these box plots say that the data falls in between 9 and 9.5? We still have our median there. You could see that we're right there at 9 1/4. And then if you're looking at Margot's data, she's got a really condensed box. And a condensed box as a quartile is a pretty good indicator that a lot of your data falls in that section. So a good chunk, 1/4 of her data falls in between 9 and 9 1/4. So her data really, to me, is indicating that a 9 to a 9.5 would be strongly advised. These boxes are fairly condensed around that area of 9 to 9.5. Ravi's data, you might be convinced otherwise because of the size of those boxes. This box being stretched out as far as it is means that there's quite a span between 9 1/4 to 10, and really 9 1/4 to 10 1/4. Like from here to there, that's half of the data. Half of the data suggests more than 9 1/4 sleep. Okay, so that's one way to look at this. And like I said, there's more than one answer. However, half on the other end of this is suggesting less sleep. But we do kind of have this box is fairly stretched out, suggesting 1/4 between 9 1/4 and 10. That's a good chunk of the data that's spread out. And then we have a smaller condensed box down here that is emphasizing, between 8 3/4 and 9 1/4. And then again, it's stretched out again here, meaning that data is just kind of scattered. There's not a clump or cluster in one area. This is showing we have a cluster that kind of falls here and not so much of a cluster, but then we have another cluster that falls here because that window is so tight. So being that our cluster is right there at the benchmark we're talking about of 9 and our other cluster is way above that, I think the idea of trying to encourage that less sleep is needed, it won't be supported. That you should be in that 9 or above range, and both of these graphs would indicate that. And I'm going to go back to Margot's. You could see there would be a cluster here, and then our next smallest region, a cluster here. So both of them show clusters right in that benchmark we want, and then a higher one. If we had flipped these around and the clusters were more on the front end near 8, then you might suggest less than 9 hours is needed.